3, 2, 1, and 0. And the liftoff of the Falcon 9 rocket and the Dragon spacecraft, packed with science and supplies for the International Space Station, humanity's home in low Earth orbit. Falcon 9 has cleared the tower. And confirmation of Max Q.
Dragon separation confirmed.
And as the Dragon unfurls its solar wings, the spacecraft will continue on its journey to the International Space Station. Good evening and welcome to NASA's Kennedy Space Center in Florida for the SpaceX CRS-14 post-launch news conference. As you just saw in the video, we had a successful liftoff at 4:30 p.m. and Dragon is on its way to the International Space Station with over 5,800 pounds of cargo, science experiments, and more. I'm pleased to be joined for more about this mission by Joel Montalbano, Deputy Manager of the International Space Station Program at NASA's Johnson Space Center in Houston, and Jessica Jensen, Director, Dragon Mission Management at SpaceX. Hello. Thank you for joining us. We'll begin with opening comments, and then we'll turn it over for questions. Joel?
All right, well, another great day for the International Space Station and our international partners, our domestic partners. I want to congratulate SpaceX for just an outstanding launch campaign, and another Dragon in orbit puts a smile on our face. So anytime you have a mission going to the International Space Station, whether it's bringing cargo or crew, it's something that we look forward to. We plan, we do a lot of planning for it, and it's just a great day. And so as we talked earlier, this Dragon particularly has inside about over 2,000 pounds of science and research hardware that our crews will be using on orbit. We also have the capability, as most of you know, with the Dragon to bring back payloads that bring back science. With the landing of the Dragon spacecraft off the coast of California, we get those early return samples. We get them back to Houston within, just 24 hours or so, and they're in the scientists' hands so they can go off and do their science and research. So we're really excited to have another Dragon on orbit. This is the first SpaceX mission for 2018. We're looking forward to more of them. And this spacecraft will be on orbit with a capture this Wednesday, about 7 o'clock KSC time, and it'll stay on board the space station for about 30 days. Thank you again, and with that, I'll hand it over to Jessica.
Good evening. So yeah, we had a beautiful Falcon 9 and Dragon launch off Space Launch Complex 40 today. This actually marks SpaceX's 7th launch in just 3 months this year. So just an exciting time. We did have a weather nail-biter today. There was an anvil cloud with the potential for lightning heading our way at about T-minus 15 minutes, but luckily it stayed just far enough away that we were able to go for launch today. I can confirm that Dragon is in a good orbit, the solar arrays have deployed, and the prop system is operating nominally. The next thing to occur is the guidance and navigation. The guidance and navigation system is housed in a bay. That door will be opening shortly. And like Joel said, we are headed to the International Space Station, and we should arrive for rendezvous at approximately 7 a.m. Eastern Time. After berthing, the astronauts aboard the space station will unload about 5,800 pounds of crew supplies and payloads. And then we'll return to Earth approximately 1 month later, where we will splash down in the Pacific Ocean. So yeah, this was our second mission to date, launching a flight-proven Dragon atop a flight-proven Falcon 9. So all around, it has been a successful mission so far and a great start to the year. I want to thank NASA, the Air Force, and the FAA for their support and hard work, especially their hard work over the weekend. It was a holiday weekend for Easter to ensure that today's launch was a success.
At this time, we'll begin with questions. For those of you not in the room, you can ask questions using the hashtag AskNASA. And we'll begin in the room, so please raise your hands if you have a question. Wait for the microphone. We have those in the room. And state your name and affiliation and to whom you're directing your question. And we'll start here in the front.
Hi, Ken Kramer, Space Up Close and Rocket STEM. For Joel, can you give us a little bit more detail, please, on the cargo missions for the rest of the year, as well, from here as well as Antares? I think you got one coming up in May sometime. Can you go through a run-through of what these will do, and when are we going to bring the next IDA up to?
Okay, so let's see. The next orbital mission would be in May, the second half of May. And so that'll be out of Wallops Island again. We have a let's see, we have a Soyuz launch and landing in June. We have a SpaceX mission, another SpaceX mission in June. And then the late summer, we'll have a Japanese cargo mission. The HTV will be in probably mid-September-ish or so. As far as IDA, I'll go back and look at my notes. I believe the latest date we're looking for IDA is SpaceX 18, I think is what we're planning to now.
Is that what you say too?
Yes. He tells us when to fly it.
Jim Siegel, Spaceflight Insider. I'm interested in the relative velocities of the International Space Station and Dragon as it approaches. So how fast is the ISS going? And I thought it was 15,000 miles an hour, but maybe that's wrong. But how fast is it going, and how many thruster firings are there typically for the Dragon to be able to catch it?
So I believe the space station is going 17,500 miles per hour, approximately. And obviously, as Dragon gets closer to the space station, you also would like it to be going 17,500 miles an hour in the same direction. So that is the goal. It takes, I could count hundreds to thousands of thruster firings to get there. Hundreds to thousands, yes. Lots of them are very short little blips. We start firing the thrusters immediately after, well, not immediately, within about 1 minute of Dragon being deployed from Falcon 9, its thrusters start firing. The thrusters are used not only to get Dragon from its insertion orbit to the International Space Station, but it's also used for attitude adjustments and pointing. So you need to be pointing for communications, and that's where a lot of your little burns are coming in. So a lot of those aren't helping you really get any closer. We do just have a few major burns to get from our initial insertion orbit to the space station. So that's just a few big burns, and then there's tons of little ones along the way.
Thank you.
You're welcome.
We'll stay in the front of the room.
Randy Siegel, WSTU Radio. Jessica, we know it was an expendable launch vehicle.
Correct.
When you brought it down, did you use it as a soft landing on the ocean? What was the final determination of it?
It was a hard landing in the ocean.
So you didn't try slowing it down or do anything other than that?
No, we wanted to get data. Basically, the main thing we were interested in is actually the re-entry data for this one, not so much the landing data.
Thank you.
Hi, I'm Tom Cross with Teslarati. This question comes from our writer, Eric Ralph. What work, if any, is being done to certify Falcon 9 and Dragon for more than 2 flights? And is NASA closely watching or working with SpaceX to ensure that the reuse-focused Block 5 modifications are likely to meet NASA's standards?
Yes. So on the Dragon side, for the Dragon 1 cargo vehicle, we are certifying it to be capable of 3 full flights. So some of the Dragons are already seeing 2. It will be capable of a 3rd flight. For Falcon 9 Block 5, we are expecting improved reusability from that for at least 10 flights. And yes, NASA is very involved in our certification process. We actually use their lessons learned, their requirements, particularly for commercial crew. While reusability is not required for commercial crew, it is something that we are designing in and ensuring that it meets NASA's requirements.
Yeah, absolutely. Both the space station program and the commercial crew programs are working very closely with SpaceX on the Block 5.
And any other questions in the room? James Dean.
Thanks, James Dean, Florida today. Joel, I was interested to learn that Robonaut 2 is coming back down on this flight. Can you discuss anything that Robonaut 2 has done so far in orbit, and are there still any expectations that it or any other robotic system will actively help support astronauts' work in orbit during the current lifetime of the station that we anticipate?
Okay. So a couple of things on Robonaut. As you know, we've had, we believe, an issue with the brainstem of the Robonaut. So we'll bring it home, take a look at it. That's our best assessment of what we think is the problem. The engineering teams will go ahead and take a look at it and see what the next steps are. Do you fly it again? Can we fix it? Why did it, what happened and why did it break? As far as on orbit, we've had Robonaut do some little tasks. We've had, for one example, is doing some airflow tests As you can imagine, airflow on board the space station is something that you want to make sure is working correctly. We have, from time to time, the crews will take air vent readings to make sure you're getting the constant exchange of the airflow on orbit. We've had Robonaut try that and do some, and what that does, it frees our astronauts up to do other critical science and research. So if you can have a Robonaut or that type of hardware on orbit to do some of the day-to-day or tasks that you don't really need humans, and then you can have the humans focus on more critical tasks that will require man-in-the-loop actually interfacing.
Question in the front.
Jim Siegel again from Spaceflight Insider. Just as a follow-up on Robonaut, what is your vision of how many of these devices might eventually be on the space station? Or are we talking about 4 or 5 of them, perhaps? Or what was the vision originally? Or just one, or what?
No, Robonaut was not my project. The vision was bring it on orbit, test it, see what makes sense, what's capable. You have a design on the ground, and then once you fly in orbit, you really learn, is it going to meet the expectations? As far as how many Robonauts, I don't know. We can go get that information for you. The plan is to go bring this one down, understand why it failed, and then make the decision of where we want to go in the future.
Just as a follow-up on Robonaut, to what extent is the Robonaut being disassembled and stuffed into the Dragon to return? Are the arms and legs coming off and all of that? Or do you know that?
I do not, but I can get that information for you. We can follow up after.
Thank you.
Any final questions? All right.
Jacob on social media would like to know what kind of research hardware is loaded in the Dragon.
Okay, so we have a handful of research. We have both internal and external research on orbit. I think Pete Hasbrook talked a lot about it yesterday, and I guess in the upcoming missions. As far as the research we have, just a couple examples. We find some simulated gravity hardware, so hardware on orbit that can generate up to 2 times the force of gravity. And you can put plants in there, you can put fruit flies in there, you can put cells, you can do a handful of things with that. We're also flying rodents for the Japanese Space Agency. We're flying 12 rodents up and returning 12 rodents live on board of SpaceX. And we have a whole press package that lists the entire contents of what we're flying.
And that's all the time we have for today. The next televised event for this mission will be Dragon arriving at the space station on Wednesday. NASA television coverage will begin at 5:30 a.m. Eastern Time. You can tune in to live coverage at nasa.gov/NTV. You can also follow the mission on Twitter at NASA and at SpaceX, and on the web at www.nasa.gov/SpaceX. Thank you.
Thank you very much.